Okay, when is it best to use the quadratic formula? The quadratic formula, it's best to use the quadratic formula when it's not factorable, the linear term is odd, and or leading coefficient other than 1. And here are our steps. You're going to put your equation into standard form, which is setting it equal to 0. So you're going to have ax squared plus bx plus c equals 0. Then you're going to identify a, b, and c. I would plug values in to find the discriminant. And then x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. But we practiced solving for b squared minus 4ac first, determining how many solutions and what type we're going to have. And then filling in these other two values here along with this one. And I'll model that for you in case you've forgotten. Step 4 is going to be simplify the radical, which means if we need to break it down, we're going to break it down. And then solve for the variable. Okay, so here's our first example. We've got x squared minus 3x plus 4 equals 0. Now, if I try to factor this, this is not factorable. I know we're thinking 4 and 1 is a difference of 3, but remember that to multiply to be positive 4, it would have to be same sign. So we'd be talking -1 and -4, which is multiplies to be positive 4, but adds to be -5. If we used +1 and +4, that multiplies to be positive 4, but adds to be positive 5. So the only way to get this -3 from a 4 is if we have different signs for the 4 and the 1, and that's not going to multiply back to be a positive 4. So this one's not factorable. Therefore, we're looking at possibly completing the square. The problem with completing the square is that our linear term doesn't have an odd coefficient. I mean, it doesn't have an even coefficient. It's got an odd coefficient. So when that's not even, it's hard to cut that in half without using fractions. Half of 3 is 1.5. And then you'd have to take 1.5, square it. It's kind of messy. So quadratic formula, that's the best option right now. And that's what I'm going to do. I'm going to identify A, B, and C. This is in standard form, so A is 1, B is -3, and C is positive 4. I'm going to find b squared minus 4ac first. B squared would be -3 times itself, which is 9, minus 4 times 1 times 4. That's going to be a 9 minus, and then 4 times 1 times 4 is 16. 9 minus 16 is -7. So we're going to have x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The opposite of b is positive 3. We know that inside this radical, we're going to have a -7. And then I've got 2 times 1 in the denominator. X equals 3 plus or minus. I'm going to take out an I. The square root of 7 remains because we don't have any pairs to help that out. and it's going to be all over 2. Now we can write this as 2 answers. 3 over 2 plus or minus I times the square root of 7 over 2. So this 2 goes to both terms in the numerator. And that's actually how I'm going to show my answer. X equals 3/2 plus or minus I times the square root of 7 over 2. However, this answer would also be correct, but we need to make sure that we can recognize that both of those highlighted answers are the same. Okay, here's example 2. Now, if you'd like to try example 2, I think that would be a great idea. Press pause and give it a whirl, and then come back and check your answer. 4x squared plus 10x equals -7. If you're coming back, thank you for giving this a try on your own. And now we're just checking your work. I'm going to add that 7x, or that, I'm so sorry. I'm going to add that -7 by adding +7, or I'm going to get rid of that -7 by adding +7 to both sides, equals 0. I'm working on the next step in my head, so I'm saying the next things that I want to say. And I apologize, I'll slow myself down. Now, factoring this, there's no combination that's going to multiply to be 7 that when I do the outer and the inner is going to give me a +10. With practice, you'll be able to kind of see those different combinations that are available and that none of them are going to work. So what we're left here is the quadratic formula. A is equal to 4, B is equal to 10, and C is equal to 7. So I'm going to start over here with B squared minus 4AC, figure out what that value is. I'm going to have 100 minus 4 times 7. Now 4 times 4 times 7, I believe is 112. 16 times 7, that's 42, carry the 4. 7 plus 4 is 11, that is 112. 100 minus 112 is -12. So that means I'm going to have 2 complex solutions. X equals the opposite of B, which would be -10, plus or minus the square root of -12, all over 2 times A, which would be 2 times 4. X equals -10 plus or minus. I know I'm going to take an I out, which will give me I times the square root of 12, but then I've got to break down the 12. 2 goes into 12 6 times, 2 goes into 6 3 times, so I'll be able to take out not just an I, but a 2I, and I'll have a 3 left over, and that's all over 8. I'm going to look for something that goes into a number that goes into -10, 2, and 8. If my denominator is positive, I'm going to divide by a positive number that goes into all 3 of those. If my denominator is negative, I'll divide by the negative number that goes into all 3 of those. So I believe that 10, 2, and 8 would be divide by 2, divide by 2, divide by 2. -10 divided by 2 is -5, plus or minus I times the square root of 3, all over 4. This is one way to write this answer. However, this 4 is going to go with both terms in the numerator. So we'll have X equals, as another option for you to recognize, X equals -5 over 4, plus or minus I times the square root of 3 over 4. Just make sure your fraction bar shows very clearly that that radical is only in the numerator. And that is how you solve by the quadratic formula. Now in the next lesson, we're going to, next video, same lesson, next video, because we're trying to keep them short. Next video will be factoring at an advanced level, and then the square root method. And those will go fairly quickly, so hurry on back and we'll see you in the next one.